2. Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, Optimizing Kubernetes Cost Strategies, brought to you by Fairwinds. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to watch it again. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinars, and it will be available there for you as well. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. We also have a Kubernetes best practices guide for 2021 in the handout section, so be sure to check that out. And we also have 2 polling questions during today's event, so we'd appreciate it if you could take a couple of seconds to submit your answers when you see those come up on your screen. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. Joining me today is Kendall Miller, President of Fairwinds, and Robert Brennan, Director, Open Source, Fairwinds. And with that, I'm not going to put myself on mute, turn off my camera, and let you begin.
All right. Well, good morning, good evening, good afternoon, good all the things like Julio said. Glad that y'all are here and welcome. This is Problems with Kubernetes Cost Strategies, where we're going to talk about the complexity of cost management, cost strategy, cost estimation, all the things you need to think about as it relates to Kubernetes. And hope you're here for that because that's what we're going to be talking about. We're excited to be here today. Let's go ahead and dive into some of the details here. So first of all, my name is Kendall Miller. I'm president at Fairwinds. We're a Kubernetes company. Tell you a little bit more about that in a second. And been at the company for about 6 years. We've been doing Kubernetes for the vast majority of that time. It's a world that I live steeped in for good and for evil, depending on the day. And excited to be here, excited to talk about Kubernetes cost with you. And Robert, would you like to introduce yourself?
Yeah, my name is Robert Brennan. I'm Director of Open Source here at Fairwinds. I've been building software for a little over a decade, been in open source for about 6 years, and I've been working on Kubernetes for about the last 3.
All right. And tell you a little bit more about Fairwinds. We are a trusted partner for many companies for Kubernetes, all the things, handling governance, security, helping ship cloud native applications faster. The short of this is we've been in business for 6 years, as I mentioned, about 6.5 now. We started as a services organization, make my infrastructure problem go away. So we have built and maintained lots and lots of Kubernetes infrastructure for lots of companies, many clusters across many different kinds of verticals and different kinds of organizations, from healthcare to media to manufacturing tech, you name it, we've done it. If it can run in Kubernetes, we have probably touched it at some point. And as a result, we started seeing some of the macro level problems that people have in Kubernetes. And we write a bunch of open source to address those things. Everything from getting resource requests and limits just right, which we'll touch on a little bit today, to managing role-based access control, to just common misconfiguration errors. And we have a whole bunch of open source. I can almost guarantee if you're using Kubernetes today, there is something that we have in our open source world that is relevant to you. And you can go check that out. We'll point you to a few different resources. But then also in the last couple of years, we have married together a bunch of our open source as well as some third-party open source. And we've built a software product that addresses compliance, governance, security, as well as cost management in Kubernetes. And at the end of this talk, we will be giving a brief demo to show you what that looks like. So stick around for that. The reason we're talking about cost is because it's one of the big things that we think about. It's a part of our software platform. And so we spend a lot of time steeped in this, particularly Robert, who has had to sort through a lot of the logic on how to make this actually work. So that's who we are. That's why we're qualified to actually talk about this. And before we go further, let's pause for a second and hear from you on where you are in your Kubernetes journey. We like to collect this and see how the audiences are maturing over time too. So Julio, if you can go ahead and launch that, great. We have options of I'm learning about containers in Kubernetes. I'm planning to use it in the next 6 to 12 months. I'm only using it in testing or a development environment, or I'm using it in production. And Spend a second filling that out. Gives us a feeling for what the audience looks like today that we're speaking to. Do. And we'll give it about 10 more seconds. 5, 4, 3. Click a button quick. 2, 1. Okay. You can wrap that up, Julio. I'll look at what the results are here. Closed. Here we are. Okay, so we've got about half of you using it in production, and another quarter of you using in testing and development, and another quarter just learning about it. Nobody put planning to use in the next 6 to 12 months. Interesting. But excited to have you all here wherever you are in your journey, and we will be answering things as we go. So real quick, I see one question has already come through, but there is a Q&A spot in the platform here that we're using today. Please do feel free to ask questions as we go. We may pause and answer them in the moment. We may come back to them at the end. We will definitely come back to the questions at the end. We will try to answer all of the questions unless we're completely overrun with questions, but feel free to ask at any point. So that was a whole lot of lead up to 5 problems with Kubernetes costs and estimation strategies. Let's go ahead and dive in. Robert, you want to get us started?
Yeah, so when you're configuring a workload to run in Kubernetes, you really need to specify how much CPU and memory that application is supposed to use. Kubernetes will happily accept a workload configuration that doesn't specify those things, but without them, it's very hard for the Kubernetes scheduler to figure out how much CPU and memory to reserve for your application and to figure out if it's misbehaving, say, using too much CPU or too much memory. So you really want to think about, how much CPU, how much memory your application will use normally. And you can set both requests, which is how much CPU and memory you'll be guaranteed to have access to for that workload, as well as limits, which is basically the point at which Kubernetes will start looking to eject your application if it's using more than that amount of CPU or more than that amount of memory. So that's kind of the first thing to start thinking about is what would a normal CPU profile, a normal memory profile look like for my application in production. So one of the problems we often see is this issue with bin packing Kubernetes. So here in this example, we have a workload that, say, uses 2 CPUs and 2 gigabytes of memory, and we're using nodes that have 5 CPUs and 5 gigabytes of memory. So the issue here is that, if this is the only workload running in our cluster, Kubernetes will try and fit as much of it onto a single node as it can. But because we can only fit 2 of them inside of a single node, and we're left over with 1 extra CPU, 1 extra gigabyte of memory, we're always going to have this waste for every node. So you can see here, the first 2 fit nicely inside of a single node, but when we go to spin up a third pod worth of this workload, Kubernetes needs to get a new node, which is going to cost you more money, and it's not able to, say, split a single workload across 2 different nodes. Right? It has to provision all of that CPU and all that memory inside of a single node. So you end up having to provision 2 nodes for what might have been able to fit inside of a single node, and you end up with this waste at the edge of each node of 1 gigabyte of memory and 1 CPU. So the solution to this type of problem is often to right size your nodes, to find nodes that fit that your workload can fit neatly into. This becomes less of a problem with the larger nodes you use, but it's important to kind of consider, based on the workloads that you're running in Kubernetes, especially if you're not running a wide variety of workloads, to figure out, okay, what is the right size node for these workloads to fit into.
Yeah, and I unmuted to say something before I moved on to this slide, or I failed to unmute. I started talking but didn't unmute, so sorry, Robert. So part of what matters in this, and just to go back to level set a little bit, if you're new to Kubernetes, in the old paradigm, you went and picked a virtual machine and you told the cloud how big you wanted that virtual machine to be, and you ran your application inside of that virtual machine, and so you were setting your resources. You were setting your limits on resources by doing that, by choosing the size of the machine. Now, Kubernetes is handling a lot of that logic for you. It's packing things into a single machine, virtual machine. There's a reason we call them nodes. So these abstractions are getting deeper and deeper. But it is the beauty of Kubernetes that you no longer have to provision in very specific ways all these different instance types and handle a lot of the logic that goes on. You're literally just giving it to Kubernetes and letting it do its thing. And to Robert's point, you don't have to set resource requests and limits. You just run into problems. If you don't, we'll get into that in a second. It may sound like one extra step, but it's something we've always been doing. It's just a different way to do it in Kubernetes. So I feel like it's important to state that. But talk about resource asymmetry, and I really like the Tetris pictures here. But
yeah, so resource asymmetry comes up when your application tends to use a lot more CPU than it does memory, or a lot more memory than it does CPU. You can see in this example here, we have a workload that uses 3 CPUs and only 1 gigabyte of memory. I'm kind of making up these numbers just to make the math very easy. Typically, there's kind of a standard ratio of CPU to memory, and some workloads are more CPU intensive, some workloads are more memory intensive. And likewise, if you look at any cloud provider like AWS or GCP, they will provide you with sort of standard vanilla nodes, as well as memory optimized nodes or CPU optimized nodes. So if we have a CPU intensive application like this one, you can see, if we go to fit another of these L blocks in there, there's plenty of memory left over for that piece to fit in there, but there's not enough CPU for it to fit in. So what we should do is use a CPU optimized node, which will give us a lot more room in the CPU column without us having to spend all the extra money for that memory that's not going to go to use.
And I feel like I need to add, as helpful as these Tetris pictures are, one thing that's different about this from Tetris is you can't just rotate that and say, oh, well, we'll just make this workload use a whole bunch of memory and not CPU. That's not how it works. It's always going to be in that L shape. It can't be an upside down L that just fits snugly and nicely in there. So to be clear about that analogy, because we look at this and we're like, oh, I'll just rotate that. Our brain automatically does that, but that's not an option.
That's a good point. Thanks.
Yeah. Okay.
Cool.
Yeah, talk cost attribution. This is where it gets complicated. We're trying to make sense out of all these different Tetris pieces that we're plugging in.
Yeah. So, I mean, at the point that you've got your bin packing working correctly, you've picked the right nodes, you've picked memory optimized nodes or CPU optimized nodes based on, how much memory and CPU your workloads use. You've got the right size nodes in place. You might want to try to get to the question of how much does each individual workload cost me? How much does my API server, cost me more than, say, some internal process or, your internal GitLab instance or something like that. And this is not an easy thing to do in the new world of Kubernetes. In the old days, you might have been able to just say, okay, well, I'm running this API server across this many VMs of this size, and therefore I can just total the cost of those VMs, and that's the cost of that workload. Pretty straightforward. But in Kubernetes, because Kubernetes is going to basically take a pool of VMs and then try to bin pack different workloads into different virtual machines, there's not really a one-to-one cost of workload to virtual machine. So what you really need to look at is, okay, how much CPU and how much memory is this workload using? And then with that, you need to figure out how well does it bin pack. So the optimistic method of cost attribution would basically say, okay, come up with a cost per gigabyte of memory and a cost per CPU roughly for all the nodes that this workload might run on. Basically an average cost per VM. And then, assuming that this workload is going to be bin packed very effectively, and you've optimized, your node types and all that, you can basically say, okay, let's assume that half of that cost is going towards the CPU, half of that cost is going towards the memory, and we can just take the average of the two. There's also a more conservative method if you haven't spent a lot of time optimizing your node types that basically says, okay, maybe this workload isn't going to get bin packed effectively. Maybe, it uses a lot more CPU than memory. And, there's going to be some memory waste anytime this workload goes into a machine. And you can use this more conservative method that takes the maximum of the CPU cost and the memory cost.
There's somebody asking if the sound is muted, so I'm responding here saying, can you not hear us? Because I can hear you just fine, Robert. So I think it's probably that one person. So like when you're talking about this optimistic versus conservative, part of the reason that we have to do that is because of bin packing. And like you showed the picture about bin packing, but it's literally, imagine a very large box and you're given a bunch of workloads, and you're just trying to figure out the most efficient way to put it in there. And Kubernetes has an algorithm for how they do this. It's very complicated. It does not involve your partner stopping you and saying, wait, I can do this better, and taking everything out and putting it back in a different way. Although your organization may say, to Robert's point, let's make those nodes a little bit bigger so that the bins can be more effectively packed, or a little bit smaller, as the case may be. Picking the right size bin is really important. But then we have to look at how this machine is going to take all these things and shove everything into a bin. And so the estimation, I'm just reiterating what Robert's already said, but where in the old days you picked the number of instances you wanted and you ran your workloads on it, and you had a very clear, direct path to that. Now, if you were auto scaling, you maybe stopped at some points, but it's really difficult in Kubernetes world, where you're letting a computer take over the logic for that, to understand exactly how it's going to do things. And that's because in real world situations, the way it packs bins are going to change. The way that your workload, the way that your application is scaling based on demand, is going to constantly change dynamically. And so we're having to estimate based on what does the workloads look like for the last several weeks? And so therefore, let's tweak it this way. And we can probably say you're going to about spend this much, or you've about spent that much. And so it gets a lot more complicated, which maybe is obvious. I don't know. Cost attribution, the whole point of this slide is the attribution is difficult, but I feel like just restating that another way is hopefully helpful. Talk about resource ranges, Robert.
Yeah. So one of the issues here when trying to figure out how much a particular workload costs is the fact that you can set both requests and limits for a workload. Again, requests are the amount of resources that are going to be reserved for your workload, so it always has at least that much available to it. And the limits are basically room for that workload to burst up. As long as those resources are available on the node, Kubernetes will allow your workload to use them. But if they go over those limits, then Kubernetes will pretty quickly evict your workload.
Say more about that real quick. What does it mean when Kubernetes evicts your workload? It starts using too much and Kubernetes just shuts it down.
Right. Yeah. So say you've set a limit of 1 gigabyte of memory for a particular workload, and that workload starts using 1.5 gigabytes of memory. Maybe there's a memory leak or something like that. Kubernetes will basically prioritize that workload for being evicted, and it'll just be that one pod, right? So it will basically kill that one instance of your application and try and start a new one, with a whole fresh pod. If it keeps trying to use more memory than the limits have been set to, it will basically keep restarting, and you'll get into a crash loop. So you should really set your limits, safely above what you think your application would feasibly use. That way, it helps you to catch things like a memory leak. It keeps the workload from just hogging up all the memory that it can. It's a good just kind of sanity check to make sure your workload's running healthy, to set those limits.
Yeah.
On the CPU side, I should note too, Kubernetes won't actually evict your workload for trying to use more CPU than you've set the limit for. It will just throttle the CPU usage. So if you set it to maximum use 2 CPUs, Kubernetes will, once it starts using 2 CPUs, will basically slow your process down and give it fewer cycles on that CPU.
So your process is still going to work. It's just going to work slowly, sluggishly. It's not going to be working the way you want it to work.
Exactly.
And it's not going to automatically evict it as a result. So having the wrong memory requests and limits might cause workloads to get kicked out and restarted, which may work fine, may not. Having the wrong CPU settings may cause your service to run slowly and have problems there, right?
Exactly. And when it comes to cost with these resource ranges, the tricky thing is figuring out whether you want to use those requests to drive the underlying cost, if you want to use the limits to drive the underlying cost, if you want to use the actual usage, which will be, likely somewhere between requests and limits. Which number to use gets very tricky. You can actually have, if you were using limits, say, you might have, if you have say 2 gigabytes of memory available on a particular node, you might actually have workloads that have a total limits of 3 gigabytes. Like you can oversubscribe to your limits. So if you use the limits to do your cost estimation, you're probably going to severely overestimate. If you just use the requests, you're probably going to underestimate. So usually we recommend some combination of requests and the actual usage that might spike above requests.
Sounds good. Okay, let's go on to problem 5. I think this is one of the more amusing ones, noisy neighbors.
Yeah, so noisy neighbors is the fact that basically you might set your requests and limits, or maybe you don't, and some other workload doesn't set its requests and limits, and it has a memory leak, say. If neither of you have set your requests and limits, that memory leak workload might steal all the memory that your workload needed, and your workload ends up struggling. It ends up not having enough CPU, gets totally slowed down because you haven't really told Kubernetes, hey, I need at least this much memory, I need at least this much CPU. If you set those requests, you can avoid any mistakes that your teammates might make. So any other workloads that failed to set the requests and limits and end up gobbling up too much memory and CPU, as long as you've set your requests, you're guaranteed to have at least that much. So it's a really important thing to avoid, and to avoid being impacted by other teams to set your CPU and memory requests.
And to be clear, like Kubernetes failure mode for this is to do the best it can if you don't set these things.
Yeah.
It's just that it can't do a very good job if you don't. And
Exactly.
that's why, like, as I mentioned, we've always been setting resource requests or resource limits, as the case may be. It is different in Kubernetes, but this isn't something that's new or should be overwhelmingly annoying. You may want help knowing how to get those things right, but did you dive into Goldilocks already? I don't think you did.
Oh, no. So Goldilocks is a great solution for figuring out exactly what you should be setting your CPU and memory settings to. Goldilocks basically will monitor the actual usage of your application. It'll watch how much memory and CPU your application uses over time, and then it will make suggestions as to what you should set your requests and limits to. Typically, we say for workloads that are like production grade workloads that you really want to be available all the time, want to be high performance, set requests and limits at the same level, and make it as high as your application would reasonably use. For more kind of development workloads, test workloads that don't need to be 100% reliable, you can set those limits well above requests, and that will basically allow your workload to function reasonably. And then if it needs to take up some extra resources, it can hopefully Kubernetes will find the memory and CPU to give it within those limits.
Great.
That's a good way of seeing money.
So with that, Goldilocks is showing you what your current resource requests and limits are, and then what you should set them on based on the quality of service that you're shooting for.
Exactly.
Really, like, this tool exists because everyone struggles with setting resource requests and limits. If you're new to Kubernetes, you don't know how to do that. You don't know what it needs. So you can pick something and use it for a little bit, and Goldilocks will help you figure out how to optimize it. So we're trying to solve that problem in part because we know that everybody struggles with it. And to be clear, Goldilocks is an open source solution. Anyone can go use it. There's the link right there to our docs for it, but it's in our GitHub as well. If you search for Kubernetes Goldilocks, it will come up. But this is one of those. We saw that everyone has this problem, and so we're trying to make it easy for you to solve. So. Yeah. Okay. App right sizing, cost optimization, and why it matters to teams across multiple clusters. And it gets hard. So talk a little bit about that, Robert.
Yeah. So, figuring out exactly what the right amount of CPU and right amount of memory to provision for your application is hard. A lot of folks, when they first get into Kubernetes, when they first launch a new application into Kubernetes, they just make a best guess, and usually they way overshoot. Right? It's your application is not going to crash if you give it too much memory and too much CPU. So usually we see development teams just provisioning, 5 gigabytes of memory, 5 CPUs, just exorbitant amounts of resources to make sure everything works fine. They're not going to get paged, et cetera.
You don't want to get paged, and I understand you don't want to get paged, but also I don't want to spend a fortune because you don't want to get paged.
Exactly.
Keep going.
So yeah, so it's important once you do that first launch, even if you do over provision for that first launch, which is reasonable, to look at the live traffic to your application, look at the live usage of memory and CPU over time, hopefully over a period of weeks at least, so you can see any cyclic stuff, like maybe you have a lot more traffic during the day and it needs more CPU and memory then, but at nighttime it gets sleepy. So you can basically monitor that live memory and CPU usage and sanity check those memory requests and limits. If your application is only using about 1 gigabyte of memory at any given time, but you've requested 5 gigabytes of memory, you're basically spending 5 times more money than you actually need to on that workload.
Right.
So it's important to constantly refine those requests and limits over time and make sure that they're roughly in line with your application's actual usage.
Great. Yeah, I know many organizations where, they're trying to enable service ownership. And so they're trying to push all of the settings around every single application down to the developer level. And if, to be clear, at any sufficiently large organization, it's very difficult to do operations in a model that is not service ownership focused, and where the people who are writing the code are responsible for it all the way through to production. Well, part of being responsible for it all the way through to production is being responsible for the memory requests and limits, the CPU requests and limits, the cost of the service that you're running. And I have friends who are leaders in organizations where they wake up one day and, they get their AWS bill and it is $50,000 more for one application than it was the previous month. And there's no reason other than somebody tweaked that and didn't know, or had dramatically over-provisioned something and didn't think about it, or whatever it is, or just didn't set requests and limits and Kubernetes went crazy. There's all kinds of ways that this can come back and bite you. And at any sufficiently large organization, having insight, the right kind of visibility, is an essential part of cost optimization. So if your organization is at the point where they're like, we need Kubernetes to cost $2.28 per month, that number can be anything, $2,000, $2,228.15 a month, that make that hundreds of thousands. It's very, very difficult to do that in Kubernetes down to any kind of real specific granularity, but it's actually very easy with these kinds of tools, with this kind of thinking, to optimize for the best case scenario, which is what we find most organizations are really wanting to do, is get that configuration right. So speaking of which, we have a software tool called Fairwinds Insights, a piece of software. I'm told regularly I shouldn't ever call it a tool, but it's one of those things that sticks in your head. So this is a piece of software that we built, as I mentioned, to help our customers get things right. And that includes the cost piece, which I'm going to pull up and show you in just a second, as well as a whole bunch of other configuration details. Before I dive into that, I just want to show that less than 30% of Kubernetes workloads have requested CPU set. An overwhelming percentage of containers are using less CPU and memory than their defined requests. There's all kinds of problems going on in Kubernetes world, but we know that people don't set requests and limits, or people wildly over provision, and it's easy to get that right. So let me pull up Fairwinds Insights and show a little demo of that. Anything you want to say before I do that, Robert? Did I skip over anything that you were going to wrap up with?
No, I think you nailed it there.
Okay. So let's dive in. So this is Fairwinds Insights, something that we have built to help you get configuration correct in Kubernetes. Now, that configuration involves all kinds of things, from cost to security and efficiency and reliability. I guess cost is the efficiency bit there. There's other things, but when you log into Fairwinds Insights, you get an overall health score on your organization, and this is across however many clusters you have. So this organization has 2 clusters running, one with a slightly higher score than the other, and it averages them out, and we're showing the number of action items, things that need to be acted upon to improve the cluster, as well as the trends. How have things improved or gotten worse over time? We also show you top issues. So and click into this, into either of these clusters, and get an overview of just that cluster. So you can see when action items were introduced to the cluster. You can see the health score of that. We also have some cost analysis right here, and that just gives you an overview of what cost has done. And I'm going to dig a little bit more into that real quick. But before I show you that, let's look at action items. So one of the things that we're doing is bubbling up a whole bunch of things that your team needs to go fix. And that can be security related. Most of the critical issues tend to be security related because, the security issues are going to cause you the most trouble and pain if you don't fix them, but you can sort by efficiency or reliability or whatever. So here's, workloads that don't have CPU request set, right? This is something that should not be happening. You can come over here and create a ticket, kick that out to Jira or something else that you're using. You can assign it to a person right in the GUI here, or you can say it's working as intended or I'm not going to fix it. Where is all this coming from is we pull in a bunch of reports from a whole bunch of different places. So as I mentioned, we married a bunch of our open source. So Polaris is really our tool that got this started. Polaris looks for common misconfigurations in Kubernetes, things that we saw all of our clients tend to get wrong. I shouldn't say all of our clients get wrong. We saw many of our clients struggle to get right. How's that? That's things like setting resource requests and limits. It runs a whole bunch of different checks just on common misconfigurations that we've seen. We also check for out-of-date Helm charts with Nova, deprecated APIs with Pluto. Goldilocks, that tool that we just mentioned, is integrated here. We do some additional things on top and above and beyond Goldilocks with Prometheus metrics as well. But we also integrate with Trivy, KubeBench, KubeHunter, KubeSec. Excuse me. And we have support for OPA, the Open Policy Agent, to write your own custom checks. Excuse me. And so that's all pooled together into that big list of action items. But, and I want to come back to that, but let's look at the workloads tab here, which is going to be the cost piece, since that's why you all are here today. And you can see we're breaking down a whole bunch of different things here. Relative daily cost across all the different workloads, so you have a visual of what's costing you the most. Relative total cost, you can see that Jenkins in this particular cluster is what's spending a quarter of our money. And then you can see daily costs. So there's times where it spikes down to nothing, or is staying up at approximately where the average is. Down here, we're showing total cost as well as total cost with recommendations. So this is only one pod. We're talking about a $7 a month difference in cost. And this is actually encouraging you to increase the requests and limits that you have set. So again, we're approaching the problem less from this tool is going to save you money all the time. And it probably will save you money because the vast majority of workloads are over-provisioned or not provisioned. But we are also going to tell you when you have under-provisioned something. And if you want this to work the way that you want it to work, you need to change those numbers. And we'll show you what that's going to cost you. And again, you can set the quality of service. So you can say, well, I need this workload to be guaranteed, or I need this workload to be burstable. And that will change some of the numbers there. So you can see if it's limited, it ends up saving me a whole bunch of money. And there's certain workloads that you don't care if they're up all the time. It just doesn't matter. It's not critical. So, well, in theory, there are certain types of workloads like that. Not every organization has those. You can click into any one of these, and it's going to show you details, actual memory usage over time. This is pulling in some of those Prometheus metrics. And then we're giving you what you're requesting today, what we recommend you request, as well as the limits on that. So we're going to make this very, very simple for you and for your engineers in Fairwinds Insights, so that anyone can come in here and see those things. We also have CPU. That's the memory tab. Here's CPU. There is cost settings where you can set it based on the cloud that you're using. You can set customized costs because nobody's paying the shelf rate for most of these things most of the time. But that's what the workloads tabs look like. Again, you want the free version of this, go look at Goldilocks. You want more in-depth logic above and beyond that, come take a look at Fairwinds Insights. We're happy to show it to you. One piece I want to get into is if you wait until things are in your cluster and broken, over-provisioned, under-provisioned, insecure, etc., we've waited too long. So Fairwinds Insights does integrate into your CI pipeline. This is an example here where you're in GitHub. We've got an engineer named Robert trying to push something that's going to break things. He's running a container as root and adding insecure permissions to the container, which is really funny, even though, this is obviously built for demo sake, but it's exciting that Robert's the one breaking all these things. And you can see Circle CI pass all the tests but Fairwinds Insights has action items found and is actually breaking the deploy so that things have to go get fixed before they can be pushed into the cluster. And here we've got, a container running as privileged. That should not be that way. So we're going to show you both what the problem is as well as how to go fix it. So the average engineer can interact with it this way. They're pushing code. They're living in an environment they're already familiar with. When something fails, they click a button that loads them into a UI that tells them what to go fix. And you can also, within Insights, set according to teams, you can make automation rules around, hey, this team or this namespace always gets kicked out as a ticket to this team. You can give limited access within Insights to the right team so that they can see only the things that are relevant to them. There's lots more in Insights that we're not going to show you today. It goes on for a long time. Automation and custom policy with OPA, you can create from templates, and there's lots more to show you that we can't get into all of it, but I just want to whet your appetite. And if the configuration around workload requests and limits, around your cost and your spend in Kubernetes is important to you, Fairwinds Insights is probably a tool that's going to be relevant for you. So, well, I was supposed to show you this before I did the demo, but that's okay. What Insights is looking to do is streamline operations, right-size workloads, avoid human errors. So much of security breaches, downtime, et cetera, is human error, and putting in place a tool that's going to run governance on your Kubernetes environments, especially across lots and lots and lots of clusters. It's very difficult to operationalize. Insights makes it very easy. Write once, deploy it everywhere or enforce it everywhere. That's CI/CD, that's the admission controller, that's in production afterwards, et cetera. And Prometheus integration for historical data usage. So let's do another poll, and then we will dive into some Q&A. I know we already had some questions come in. Please fill out other questions in that Q&A tab if you have them, but let's pause for a second and ask, what is your greatest opportunity to improve your Kubernetes environment? Number one, getting help with the basics. Number two, you want a general best practice assessment, see if what you're doing is actually the right things. Number three, improve the security posture of your clusters. You feel like you're doing a lot of things right, but you want to be more secure because we always want to be more secure. D is saving money, which I'm guessing a lot of you are going to say, given that this is the name of the webinar you're here for. Or finally, improving the reliability of apps running in Kubernetes. Take a moment and click on a button. Robert, I noticed you don't try to harmonize to my Jeopardy beat. Maybe next time. Maybe we can work on that.
You don't want to hear me try and sing.
We can spend some money trying to do that at some point. Get in a voice trainer just so that our webinar wait music gets better with some harmony. We'll give this 10 more seconds. What's that, Robert?
That would definitely take it to the next level.
Definitely take it to the next level. I think it's a worthwhile investment.
Mm-hmm.
Okay, 5, 4, 3, 2, and then the last one you always give a little bit longer on. 1. Okay, you can wrap it up, Julio. And I will pull up the poll and read back to you some of the results here. So it sounds like 50%, which is the largest response we had, said getting best practice assessment would be very helpful. So that's something, again, get in touch with Fairwinds if you want to audit some of your best practices. We have white papers that talk through common problems that you might have. You can, talk with us about a proof of value on Fairwinds Insights, where we will actually set this up, run it for you, and spit out, it's going to give you a health score according to a whole bunch of different tools, right, that we're pulling in and marrying here to tell you how well you're doing. So there's lots of different ways we can go about that. Get in touch if that's interesting to you. And then we've got a pretty even split across improving the security posture of your clusters and improving the reliability of apps running in Kubernetes. Small percentage of you said saving money, and even smaller said getting help with the basics. So thanks for responding. That's helpful to know. If you want to go look at, we have this best practices guide in Kubernetes, and we focus on efficiency as one of the pieces there. So yes, we touch on security and reliability and policy enforcement, but we have a big piece on the cost optimization and efficiency bits. So if that's of interest to you, and Robert, I can hear you typing loudly. It's okay. If that's of interest to you, go check out our white paper. But let's spend a minute. We had a few questions come in, and if other folks have questions, please drop them in the Q&A now, and we'll get to them. But I like this question. Robert, how often do CPU and memory resources need to be tuned? Like, how often do we need to revisit them? Is it set once and then forget about it?
Yeah, that's a great question. I would say you should probably come back to it at least quarterly per application, especially for production applications. It's especially important, in terms of reliability, to see if you're coming close to your requests and limits. You might be starting to get throttled CPU-wise, or you might be seeing out-of-memory exceptions occasionally on the on your pods. I think if you're happy with the reliability aspect, maybe you've well over provisioned. I think at least every 6 to 12 months you want to come back and look at the whether how heavily over provisioned you are and whether you can tune down your requests and limits. The thing is, every time you issue a new version of your application, the CPU and memory profile might change. There might be some new memory intensive or CPU intensive subprocess in there. So it's ideally you would look at it with each launch, honestly, to make sure that there weren't any substantial changes in that launch that altered CPU and memory, maybe in a way that wasn't intended.
Great. I also think it depends on how important cost is to your organization. There are lots of companies that are just like, we don't care how many millions we spend. We just need to never, ever, ever under any circumstances have downtime. In which case, set some conservative things and or some very liberal requests and limits, and don't worry about it. But most organizations do care about the cost, do care about how efficiently they're spending money in the cloud. And I think it's, depending on how quickly your organization is scaling and how often things are changing in your operational environment, which is probably all the time, coming back and checking on it with some regularity is pretty important. And if you're an operator or a service owner, your boss will appreciate if you can ping them and say, hey, I just tweaked this, and this looks like it's going to save us money. In fact, that's the kind of thing that tends to get you a raise. That's one other way to think about it. Here's a question that came in briefly. How does Kubernetes fit into AWS managed services? And I will start with that, and Robert, you can tack on. Cool. AWS, first of all, has a managed service for everything. Well, actually, if they have a COBOL of some sort managed service, I'm unaware of it, but almost everything AWS has a managed service for. They do have EKS, which is their managed elastic Kubernetes service. So 5 years ago, it was very difficult to just stand up Kubernetes. Today, you can click a button, get a Kubernetes cluster in EKS on Amazon. The problem is, getting a Kubernetes cluster is not really very much still. While Kubernetes is the closest thing we have to a framework for infrastructure as code in the cloud, it's not really even a foundation. It's sort of like somebody giving you rebar and cement and saying, good luck, buddy. And if you don't know how to put that together and build a foundation, you're going to have a house that crumbles at some point. So there are managed services. It keeps Kubernetes up and running, but that doesn't mean your things deployed into Kubernetes are working right at all. That's part of why Insights exists, where as I mentioned 5 years ago, a lot of people were paying us just to stand up Kubernetes because that was the difficult part. Today, that's not the difficult part. And the reason we're still in business is now what we do is make sure what's running in Kubernetes is running right. So Kubernetes fits into AWS. It's one more managed service that they have. The whole world's going to Kubernetes. Even the managed services on AWS that aren't Kubernetes are probably running Kubernetes underneath, and increasingly will be doing so. You're going to need help in addition to some of that. So I hope that answers that. What kinds of cost savings have your clients seen? I like that question. Do you know, Robert, what our default is?
So I don't know like an average across all clients or anything like that, but I can tell you I've seen workloads that are using hundreds to even like low thousands of dollars more than they need to. We've seen teams that have provisioned multiple CPUs for a workload that uses half of a CPU. Literally 10 to even 100 times as much resources as they're actually need to be using. Because again, it's easy to over provision. Your workload's not going to crash. It's going to be fine. If the application is not crashing, nobody complains. So we have definitely managed to identify very significant amounts of literally thousands of dollars per month of savings for certain clients.
And it's one thing to be over provisioned many times and have one pod. If you are operating at any kind of scale where you have hundreds of pods running and they are all over provisioned, tweaking that down a little bit, or thousands of pods. I mean, we know organizations that run thousands of pods, and you make one small change, suddenly you can get a lot more things into those bins. It's like changing the size of the container that you're shoving into the bigger container, and you make that a little bit smaller, you can put a lot more in. So that makes a big difference. Great. Let's see. Any other questions come in? I've got one more here. When should limits be different from requests?
Yeah, that's a great question. I think we touched on this a little bit earlier, but we generally recommend that for a production grade workload, a workload that you want to always be available, to set this to exactly equal. The idea is, if you think at some point your workload might need 3 gigabytes of memory, even though it might only normally use, say, 1 to 2, you should provision those full 3 gigabytes of memory. Because even if you set, say, request 2 gigabytes of memory and limits is 3 gigabytes of memory, while Kubernetes will allow your workload to go past the 2 gigabytes of memory, it won't guarantee that it has access to that. It might be on a node that just doesn't have any more memory to give, and it'll be stuck at 2 gigabytes of memory. So it's important to really set those requested limits for production grade workloads, at the absolute maximum that you think it will ever use. For less critical workloads that are really fault tolerant, workloads that maybe are driving some internal tooling or a feature environment that can that doesn't really need to be fully responsive. Maybe it can take a minute to scale up properly in order to serve the first request. Those you can really start lowering the requests below where you would have had it for the production grade workload. You probably want to keep the limits at the same level, but you can start dropping the requests so that Kubernetes won't reserve that much, but it will if somebody starts using, say that feature deployment, it can warm up and start moving into that limit range.
Okay, great. And we had another question come in. This is exciting for me because I believe this is a name that I recognize from a former customer of ours a long time ago. But the question is does Goldilocks work well with JVM apps? We use the Kubernetes VPA in recommendation mode, and it's not able to give us good recommendations.
Yeah, great question. Java is particularly poorly behaved in Kubernetes because it takes a lot of memory and CPU. I think particularly a lot of memory at startup time, and then after a certain amount of time, it cools down and starts using less memory and doesn't need as much going forward. Goldilocks does use VPA in recommendation mode underneath the hood. So if you're not seeing good results with VPA in recommendation mode, you're probably not going to see good results with Goldilocks. Although we are working to potentially tune that or basically replace that VPA engine going forward with something that might work a little bit better. I think using, say, Prometheus or Datadog to look at the minute to minute memory and CPU usage of the application might help you figure out how to set those more appropriately. But again, you're going to have to really you'll probably want, in this particular case of Java, to set your limits higher than your requests, just so that it has room at that startup point and then can cool down below the requests. But yeah, Java's tough.
And Robert, do we do some of that logic in Insights by pulling into those Prometheus metrics? Will that make some of that easier? I mean, there's Goldilocks that will use the VPA under the hood and exclusively that, but in Insights, we're also pulling in those Prometheus metrics. Will that help make some of those recommendations easier?
Yeah, so within Insights, you'll be able to see, over a long period of time, what was the maximum amount of memory that a pod used, what was the average amount of memory that a pod used, and you'll get recommendations for how to set your CPU and memory requests and limits based on that. So it will definitely help.
Great. Well, great. And I think that's all we've got for questions. So we're wrapping up a few minutes early, but that's good. I always like it when we end a little early because then people are excited to come back to our next one. Julio, I'm going to turn back over to you, and we will do a drawing here, I think.
Yes, we will. But first, as a reminder, today's webinar has been recorded. So if you missed any or all of the webinar, you will be able to watch it again. We'll be sending an email with a link to access the webinar on demand, and it will also be on devops.com. Just look in the on-demand section in the webinars page, and it should be there. Our 4 Amazon gift card winners today are Julian R. Congratulations, Julian. Our second winner is Daniel P. Our third winner is Elliot T. Congratulations. And our final winner is Tiago S. So congratulations to all of our winners. We'll be reaching out to you via email with an instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Okay, so Kendall and Robert, thank you for putting together an excellent webinar, and a big thanks to the audience for their time and engagement. This is Julio Godinez signing off until next time. Be well.